My research is related to the energy efficiency of energy devices. What we're doing is we're developing a device which will permit gas turbine engines to run much more efficiently and also provide fuel flexibility for them. Because modern power plants are going to burn anything from natural gas to gasified hay and coal, and even hydrogen gas. It also looks at trying to develop a transducer with enough bandwidth that we can perform active combustion control. Modern lean premix combustors suffer from combustion instabilities, and we're hoping that we'll have enough bandwidth in our device in order to control those. We're building a very advanced valve, and this valve controls fuel flow to one of the many combustors that go into an engine. And what we've learned is that one of those combustors might make 70% of the pollution for the entire engine. And so our valve is actually going to enable us to fine-tune that and adjust it, reduce the pollution, but not only that, but make it run much more efficiently. Well, we could use hydrogen gas, which is a very popular fuel because it has no pollution. Its only product is water. But we could also burn gasified solid fuels like coal, switchgrass, even municipal garbage. Fundamentally, I consider myself an experimentalist, but experimentalists also have to be familiar with the theory and also have to use simulation tools. We actually do all three facets here. So some of our work is pure theoretical. We develop analytical models which describe the behavior of different parts of systems. Primarily, though, we use numerical modeling, and that involves a mix of computational fluid dynamics, finite element analysis to look at both the strength of the materials as well as the thermal response of the material. And then we also use software that does electromagnetic modeling. We're trying to create this device which can improve our current gas turbine engines that we use to generate electricity. And one of the fundamental problems that we're dealing with is that our dependence upon fossil fuel is just a fact of life. We cannot change that dependence overnight. It's going to take some time. So in the meantime, we have to use this in the most efficient manner that we can. A current gas turbine engine runs, I think, around 50 to 60% of efficiency, which is actually very good in terms of power generation. Our best coal-powered plants are running at a little bit more than 40% efficiency. And with some of the more advanced research that mine feeds into, which would bring together gas turbines, gasifiers, fuel cells, and put them all together, some of the predictions estimate 70 to 80% efficiency. So when you consider that the amount of energy that this nation uses, the electrical energy, that's very significant. The reason we need to use simulation tools is because it really speeds up the design cycle. In the old days, you would conceive of a device and you would build it and you would test it and see if it works. And if it didn't, you'd figure out which part doesn't work and design that part better. But today, with modern technology, we can fully simulate our device, including the actuator, the electromagnetic response of the actuator. We can actually perform CFD simulations and determine what the internal forces are going to be, what types of flow field we're going to be, which can create vibrations or other problems with the flow. And then we can also determine how strong the device is and optimize that. I think the biggest advantage of simulations with simulation and modeling is it helps show the picture to people and get people excited. Because a lot of times you can't really see what's happening inside of a device. But with the simulation, it allows us to do that. In fact, it allows us to look at things that are impossible to measure. My work is inherently multidisciplinary, and so I forged a number of partnerships with both Pitt faculty as well as colleagues from other places. Here at Pitt, I've worked with Buddy Clark and Laura Schaefer, as well as Dan Cole, and most of these people are in the energy area or controls. I've also worked with faculty from Carnegie Mellon University as well as West Virginia University. And most of those were, again, centered around my energy-related research that has been sponsored by the National Energy Technology Library, or NETL. So we've forged a terrific relationship with NETL, and there's probably a half a dozen people at NETL that I've directly worked with to help bring this research to fruition. The part I enjoy the most is when I see something work at the very end. You know, there's a lot of work and a lot of patience that goes into this thing that really I consider my baby. You know, and to watch my baby bloom and blossom and work at the end is probably tops.